Alright, so this is quiz 1 for physics 201. Which of these is the best answer considering appropriate use of sig figs? Here I have an addition. I'm going to keep the lowest number of decimal places, which is right here, so it's going to be 7.0 divided by, here I have multiplication. Keep the lowest number of sig figs. They both have 2 sig figs, so it's going to be 7.0. And so that's going to be 2 sig figs, since they're going to be our final answer, or 1.0. Let's give it a different color here. Square millimeters estimate the area of this box. We have a box that's 2 centimeters by 2 centimeters, so that's 20 millimeters by 20 millimeters approximately, and so that's 400 square millimeters. What must be the units so this equation is correct? We have meters, seconds, over meters per second equals Q times 1 over meters per second squared. See, these meters cancel, the S comes up, so I'm left with seconds squared. Q times seconds squared over meters. So Q must have units of meters to cancel out there, so the answer is A. Which of these is current standard for the kilogram? That would be the mass of a cylinder. What is the sign of the acceleration? Here I have a big negative velocity and a small negative velocity. So my speed is decreasing in the negative direction. Velocity is negative. Because it's decreasing, the acceleration has to be the opposite sign of the velocity, so it's positive. It shows a velocity versus time for 3 separate cars, A, B, and C. Which of these statements is false? Cars A, B, and C all reach the same final velocity. That's true, they all reach this final velocity. Car A initially has a larger acceleration than car B. Its acceleration is given by the slope, and car A does have a larger slope, so that's correct. Cars A, B, and C all travel the same distance. That is not true. Car C travels the area under that graph, is given there. Car B travels this distance, and car A travels that distance. So clearly car A travels a much further distance, so C is the answer. And then car C finishes with a larger acceleration. This slope is the acceleration compared to this for car A, so it is much larger. Throwing a ball straight up, travels like this, it comes back down. We know at the top that the velocity equals 0. The acceleration is minus 9.8 always, so C is the right answer. Alright, let's consider this plot. The first one, I want to know what the average velocity between 1 and 3 seconds. Right. I'll write it up here. Average is delta x, so it's delta t. That's going to be let's see, 30 minus my initial position. You could just estimate this, though at 1 second it's going to be 6 meters, but I would take anywhere between 5 and 8. That is, what is the position? I know that in particular it's 6, because I know this is the position function. If I put in t equal 1 second, I get 6. Divided by my time, which is 3 minus 1. It's 24 over 2, or 12 meters per second. B, what is the magnitude? Actually, I'm going to take out this direction. Just what is the magnitude of the acceleration at t equal 3 seconds? Alright, so I know that x is given by this function, so I can say that the velocity is the derivative of that, dx dt, which is 4t plus 4, and then the acceleration is the derivative of that, which is going to be just 4 meters per second squared. That's at all times, so it's also at t equal 3 seconds. What is the initial velocity? Right, well, the initial velocity is the velocity at t equals 0. I have a velocity function right here, so I just plug in t equals 0. 4 times 0 plus 4 is 4 meters per second. Alright, what is the velocity of this object at t equals 3 seconds? Very similar. I just say v equals 4 times 3 plus 4. It's going to be 16 meters per second. And I want you to show graphically how to find that velocity at t equals 3 seconds. So at this point, I'm going to draw a tangent line best I can. and I will estimate the slope there. It looks like I have sort of a triangle here, so we'll see how close I come out. I have 60 minus 10, so 50 is my rise, and 2 to 5, 3 is my run. So it's 50 over 3. It is here. Rise over run. 50 over 3. I know what the answer should be. It should be 16, but it looks like it is 16. Roughly 16 point something. All right, now F. Calculate the total distance traveled with calculus. The total distance is going to be the integral of v dt. My velocity function is 4t plus 4. And so if I take the integral of this, I should get something familiar to you. Notice this is just the position function. You could have started with that if you like. I'm going from 0 to 5 seconds. So that's going to be 4 over 2 times 5 squared plus 4 times 5. That's 2 times 50 plus 20 equals 70 meters. Notice 70 meters is my final position. So that all jives with what I have. And then G, sketch the velocity versus time graph for this function. Be sure to show the appropriate signs for the velocity axis. So final part, V versus T. V is positive always and increasing. I get that from the slope. It's positive here, and it's increasing as I go along. So my graph is going to look something like this. Notice it does not go to the origin here because the initial velocity is not 0. Then it actually starts at 4. I wouldn't ask for numbers, but let me just show you this. The slope of this is also equal to 4. Alright, house is 40 by 22 by 10 foot. What is the volume of the interior of the house in cubic centimeters? So let's first find volume. 40.0 times 22 times 10.0. $8,800. Alright, look, I'm keeping 3 sig figs here, so I need to recognize that this actually is a significant figure. 8,800, that's in cubic feet. Alright, so 8,800 cubic feet. Or excuse me, I'm not keeping 3 sig figs, I'm only keeping 2. So I just remember that these are the only significant figures. And then I convert this. This has to be cubed. So 8,800 divided by 3.28 cubed. I get 250 with the appropriate sig figs. That's in cubic meters, but I want it in cubic centimeters. I have to cube it. This cancels those units. Leaves me with 250 times 10 to the 6th. That's 2.5 times 10 to the 8th cubic centimeters. And that's the final answer. We could have done all of this in one step, but I broke it down into 3 separate steps. I complete the derivation of this equation. V is equal to V naught plus AT. Alright, so I take this. I gave you the definition for acceleration. I just say dV is equal to A dt. Integrate both sides. V is equal to AT plus some integration constant. V is equal to AT plus V naught. And that is the end. There are the answers to the multiple choice.